our 5G service. We have, the SKT has started like the 5G services from the last December 1st. Actually, we say world first. So this is our CEO, and then he's holding the 5G, the smartphone from Samsung. So I tried to capture the phone, but it was some confidential, so I was not allowed to share the actual the phone. But actually, we can see. But this photo is online, so I took it from there. So and before the service, we had some like 5G demo in our company internally, and I took the demo. I took the picture and the video personally for this session, and I'm going to introduce some of them. So 5G service. So we're going to use 5G service for esports, like as everybody does, and then for security and sportainment and drone, and also for productivity and social VR. And I'm going to introduce some of the use cases. The first one is the security. The SKT, this year, SKT has acquired one security company. It's called ADT Caps. So you can see this is the real bike, and that bike has a 5G camera. So this camera is taking all like the pictures and then sending those videos to the command centers, and then we can see all the streets using this kind of video. And the second one is the sportainment. So the skier is using the VR, and then that's a 5G VR. So the skier is getting the VR, the pictures from the 5G antenna, and then it's enjoying some kind of like a real ski using VR. And the second one is the drone. So okay, so we have this kind of drone service. So if we need to launch the drone, and then it drones flies, and then it's kind of it's capturing all those like the it's kind of monitoring if there is any intruder in some area or not. And then in the command center also we can assign like some area for monitoring, and then it patrols all those areas. And then like and if it detects any like the intruders, and then that's gonna be monitored in the command center. And then in this command center we can detect, like if you can see there like there's some kind of intrusion in the command center. And then if it finishes its own like the missions, and then also it goes back to its home automatically. Yeah, like this. And then the last one is productivity. This kind of it's a robot. Also, this robot is connected to 5G, and then this robot can be controlled in real time, and then in very low latency using our 5G services. Okay, this is about like the SKT's 5G services, and then I'm going to talk how we can achieve this kind of a 5G service using our like the virtualized infrastructure. Okay, this shows the edge architecture. So I think you guys are very familiar with this architecture. And this is a Mono area, and then we have implemented T-Mono. T-Mono is kind of an orchestrator. And then, so I'm going to talk about T-Mono, and then also we have a beam area, and then we have improved this beam area to CloudVIM using our some cloud technology. So in this talk, mainly I'm going to talk about T-Mono and the CloudVIM. So T-Mono Timano is exactly following the H standard. It has a beam, VNF manager and also common beam. Also, we have a local NFV orchestrator. And on top of that, we have an end-to-end orchestrator to control the multiple data centers. Packet, okay. And so let me introduce some LTE infrastructure first. We have virtualized our LTE infrastructure from 2015. And first, we started virtualization from the IoT devices. And then first, we have virtualized IoT VPC and some like the IMS features. And then we have extended to our Tunsan data center and the Seongsu data center. And the Tunsan and Seongsu are the Korean area name. And so we have extended to the IMS and then also the EPC area. And then later we have extended to more and more features. And then finally we have totally we have 4 data centers in Korea. And finally we have, like I said, maybe we have virtualized maybe 80% of all the LTE infrastructure, and then now we have more than 80 VNFs and using more than 1,000 VMs. So this is kind of our LTE virtualized infrastructure. Okay, so how we have virtualized using, like I said, using Timano. So in Timano supports kind of a dynamic end-to-end network slicing. So using we define new services from the BSS, and then that's been ordered some kind of a new lifecycle management. Some command is sent to our end-to-end network orchestrator, and then it choose any the one specific data center, and then that command is sent to our local NFV orchestrator, and then through our command beam. Command beam has our OpenStack. So then that command beam, which means the OpenStack, creates virtual link and also VMs. And later, using our generic VNF manager, we instantiate layer VNF components like this, and then we create a local network slice. And then in the other side, we create another another end of the cycle, and then we connect both sides using our transport infrastructure orchestrator, which is the SDN, which we just call TSDN. So this is kind of our end-to-end network slicing architecture. So next is common beam. So we define common beam using as a CloudVIM. The CloudVIM has a feature of some cloud features like virtual networks and then containers, and also we are using CI/CD. And also it has carrier grade performance like using normal data plane acceleration, SmartNIC like DPDK or SRV. So I'm going to present more detail about the CloudVIM. So virtual networks, we have implemented SONA from 2015. So it's almost 4 years old. So about SONA, our another member, Jian, is going to present maybe in this Thursday. So maybe you can attend to that session. And containers, we have Taco. Taco is all containerized OpenStack. So all OpenStack components are containerized. And also our SONA supports also container networks, not only the VM networks. And all those Taco and SONA are developed using the CI/CD. And data plane acceleration, we are using SmartNIC, SRV, and also the DPDK. So SONA is OpenStack. Is kind of SDN-based virtualized network management solution. So for OpenStack, So and then it supports like the full multi-tenancy feature, and also it's using VXLAN and VLAN. And also it has some kind of a scalable gateway. Also, the good thing is that it's fully compatible with OpenStack. So if you want to use the Sona, and then you don't need to change any OpenStack feature, just install OpenStack, and then if you install the Sona, and then it works magically. So as I said, the detail will be given in this Thursday from another colleague, so you can attend the session for detail. And Taco, we have developed Taco is our SKT version of the OpenStack, but actually we are using the exact same, the community version of OpenStack, but actually we are using using some kind of a containerized OpenStack the process. So originally there was the Cola. Cola is OpenStack project to containerize all the OpenStack components, and then we are using that Cola. And then we use Kubernetes to deploy the OpenStack. So first we deploy the Kubernetes using kubespray, and then later we use a Helm project to deploy our OpenStack components. And then all the OpenStack components are deployed on top of the Kubernetes, and then all those OpenStack components are managed by the Kubernetes. So by doing that, it supports like auto healing, auto scaling, and then also we can install the OpenStack in a few minutes. So it's really easy to operate and then upgrade and then manage the OpenStacks. And also, as I said, the Sona also supports like the Kubernetes container network. For now, we are using Courier to interconnect the VM from the OpenStack and the containers from the Kubernetes. And then all the VMs and then the pods are connected to the OBS. And then we manage the networks between the networks among the VM and containers using our Sona. Of course, the Sona is based on the ONF. And then now we are now implementing like the independent version of the CNI. So without using any OpenStack, we can control and then we can manage the Kubernetes container networks using Sona CNI. So it will be maybe available in next year. Also, the Sona CNI supports like all the DPA features because the telco requires the almost like the lineage features. So CI/CD also is, we are using Jenkins for like the continuous integration and the continuous deployment and continuous delivery. So as we commit any code, so all the test, or like the more than 1,000 test cases are tested automatically using our CI/CD pipeline. And then all the sources are uploaded in our GitHub site. And then also all our like the ONF image and the Sona images are already in the Docker Hub. And then using those source and then on Docker Hub, the CI pipeline is working to check any issues and some tests. And then after test or the final images also again uploaded to our Docker Hub, and then the result is reported by the Slack. And the SmartNIC and the OBS DPTK and SRV. So in the next session, so our colleague Daniel is going to present about this. So I'm going to skip this detail. Okay, so conclusion. So we have studied from this picture, this kind of the old stage, like the initial stage of the VNF. You can see there like we have VNFs, but actually we can see that those are just separated from the hardware, but it's not really using any cloud features. It's just on top of VMs. So, and then we can see that all those like the ports and the ports are strictly connected to switch. So if we move this VNF to another, and then we need to have the exact like the hardware switches and the hardware configuration. So to avoid this kind of limitations, now we are transforming into real cloud native like the BIM. So as you can see that using our Taco and Sona and any other like the DPA features, now we are moving to cloud. So any VNFs can be installed in any like the servers. Also, even now we are preparing some like the containerized VNF. It's called CNF, and also they can communicate using our Sona. So, so this is kind of our final picture of our 5G infrastructure. Okay, thank you. And do you have any question? Okay, thank you.
Well, one question.
Okay.
You mentioned the throughput-wise, what were you able to achieve? What was the throughput you were able to get?
Oh, throughput. I see. So maybe for, as I said, if we virtualize our infrastructure, and then the throughput is going to be usually degraded. And then if you use OBS, and then usually it achieves like only 6 to 7 gigabps in the 10G line rate. So that's why we had to use like the DPA features. So we are using like the SRV and PCI-PT and even the SmartNIC. So maybe you can hear the detail from next talk from Daniel. So he's going to give like the detail and how we have achieved, and then what was the final result like that. Yeah.
Thank you.
You're welcome.
Is this deployed actually, or is it just a field trial, what you were showing so far?
This one?
Yeah.
Actually, we are in the middle of this one. So we can say that we have almost moved to like, except like the containerized VNF. And except that one, we have almost moved that one. So we have already deployed the SDN deep spine fabric. And then now we can like we can install the like VNF in any like the host. Of course, in some cases, like in some VNFs require some PCI pass-through. In that case, we have to specify the host. Otherwise, like we don't need to specify the host. So I would say that maybe except that function C, meaning the on the lightweight container, yeah, it's almost there. Yeah. Okay, thank you.